Let's start our screen test. Okay, so today we're talking about two-way tables. You've probably seen these before in Algebra 2. You got probability and the addition rule. So in real life, if you ask, do you want soup or salad? The waitress or waiter wants you to choose one of those, but not both, right? Although I have tried this on an airplane and it always has worked for me. They ask me if I want like pretzels or a cookie when I get my little snack, and I say both, and they have always given them to me. It's amazing. So it's like a little hack if you want to do that. When you're riding your next plane, that's what you need to do. Or I say, what do you want to drink? I want orange juice and water, both with ice. I ask for 2 drinks. It's crazy. They give them to me every time. Okay. However, if you order coffee and asked if you want cream or sugar, it's okay to ask for one or the other or both. Does it make sense? Like some people put cream and sugar in their coffee, and that's considered okay. So we're kind of, language-wise, we're kind of wishy-washy on the or. So what do we mean? So when we say probability of A or B, we mean one or the other or both. So we're wishy-washy in that we always mean either one or both of them. But it doesn't have to be both. It's different than and. And means it has to be both. Okay. And so we're going to start with a two-way table, right? So this is a two-way table. Students in a college stats class want to find out how common it is for young adults to have their ears pierced. They recorded data on 2 variables, gender, and whether or not the student had a pierced ear, for 178 people in the class. The two-way table summarizes the data. Suppose we chose a student from the class at random. Define event A as getting a male student, event B as getting a student with a pierced ear. Okay, so B is getting a student with a pierced ear. So if I just want to find the probability of B, and again, event B is getting a pierced ear. So in the numerator would be what I want. I want to get a pierced ear, which is, there's 103 folks who got pierced ears. So 103 is in the numerator. And out of a total of 178, I don't have to add that up. The columns and rows add up to the bottom right number there. So it'd be 103 divided by 178. Get your calculator out. By the way, I'd probably accept both answers. If you wrote 103 over 178, simplified, that's good. If you wrote 0.579, that's good as well. Or 57.9%. All those are good. What's part of A and B? Now both have to be true. So A is a male and B is pierced ear. So there are only 19 folks that fit that description. So it would be 19 over 178. Again, either form is okay, which is about 11% chance. Helps to kind of talk about percentages when you talk about the answer. The proportions don't always help you that much. Okay, so probability of A or B. So now this is where it really does get tricky here. So probability of A, we said was 103 over 178. Probability of B was, if we did just the probability of B separately, getting a student with a pierced ear, B was 103 over 78, sorry about that. Male would be 90 over 178, right? So do I just add up those two numbers in my numerator? I think the problem is, do you see how the 19 is being counted twice? So 19 is part of 103, 19 is also part of 90 there. I can't double count my 19. So you're really just going to add up those 3 numbers, 71 plus 84 plus 19 in the numerator divided by the total 178. And you get 97.8%. So all but 4 of the students really fall into one of those 2 categories. There are 4 students who are female and they don't have pierced ears, so they don't fall into either category. And so if that's another way of thinking about it, 4 out of 178 would be the complement of that event happening. And again, the hard part was the fact we double counted the 19, right? You can't count it twice. You can't double count it. And so wouldn't it be nice if there was a formula for this? There is a formula for this. So that's what we would do in this problem. We're subtracting the overlap or the double counted part. This is the official formula. And so this works. This actually works for mutually exclusive events also. It's just you'd be subtracting 0. Because remember, the probability of A and B both happening at the same time is 0 if they're mutually exclusive. So technically this formula is better than the mutually exclusive formula because it works for both mutually exclusive and non-mutually exclusive events, right? Because in this case, you can have both happen, right? You can have a male who has a pierced ear. So clearly both can happen. So you have to just subtract out those when both happen. You're subtracting it out. You're adding up the two individual probabilities and then subtracting out. Again, if it's disjoint, if they're mutually exclusive, then that's going to be 0 that you're subtracting. So this formula also works for that one. So this one might be represented better a different way. I guess we could do it with the table, but it'd be better to write it out differently. Try this one. See if you can kind of think it through and get it. I want to know, do you like to just add up those three numbers? Is that how I'd get it? It seems, again, it's this idea of double counting is a big deal here. We don't want to double count. And so some folks do both, Instagram and Facebook. I don't know how that's possible because, you know, you're younger, you use Instagram, you're older, you use Facebook, or you're like me, you don't use either one. I don't know. So, but there are folks out there who wouldn't be in either category. That seems probably obvious there with the data. Okay. So uses Facebook and I uses Instagram. So we need to apply the formula, right? So probability of Facebook is 0.68. Probability of Instagram is 0.28. And then the probability that both are true is 0.25. So we kind of subtract the overlap. We don't want to double count those 25% who actually do both. So you've got to subtract it out and you get 0.71. That's the formula way of doing this, which is great. I like that way. There's other ways. We could also do a Venn diagram of that one. Like, for example, if this makes sense, so I'm going to do a Venn diagram of that one, just do it differently. So I'm going to say, you know, we've got two, whoops, let me grab a pen here. Okay, so if you've got two diagrams that are overlapping, if you remember the Venn diagram, so one of them is Facebook and one of them is Instagram. I'm going to start in the middle. So this is 0.25 in the middle. There's overlap of 25%. So really, Facebook is not really 68% because 25% of those 60, so what is that? 68 minus 25 is 33. So this is 0.33 because now you can see total, if you add up those two, 0.25 and 0.33, you get the 68%. It's just, you know, this is the overlap area is the 0.25. Same thing for the Instagram. So we know the Instagram is 0.28, but you're subtracting out the 0.25 to get 0.03. So really there's only 0.03. Wow, that's interesting. So only 3% of Instagram users in this group don't use Facebook at all, right? So they're not in both platforms. So they're only in Instagram. That's actually somewhat surprising. I would think there'd be quite a few younger folks who don't have Facebook. Maybe a Facebook too, if you're that tech savvy. A Venn diagram consists of two more circles surrounded by a rectangle. Each circle represents an event, and the overlap is the space in between. I love Venn diagrams. It's great. Just Venn it up. Okay, so in this case, we could have done that same problem we asked about male and pierced ears. So we could have always start with the middle. See, I would put 19 in the middle. And then in this case, actually, it's really pretty easy to do a Venn diagram here because it's already kind of laid out for us because there's 84 females who also have pierced ears, but they're not in. So this second circle is the pierced ears, but they're not in the male circle. So that's 84 and then 71 over there. And to get our answer of or, we would just add up all three, right? You would add up those three numbers. You can also get the, you know, the idea of the complement of, you know, there's some situations where female and no pierced ear, right? So there's 4 situations that. The complement is the opposite of that event happening or that event not happening is essentially the complement. The intersection, so that's like the outside area of the Venn diagram. The overlap of the two is the intersection of both events happening. So, you know, if 19 people did that. Union events is all three. So you take the left circle, the right circle, and the part in the middle, but you don't double count the part in the middle is the key. U stands for union. That is, union is both circles, essentially. Intersection, that's what that symbol means. It kind of looks like an N-ish, like an upside down U, but that means the intersection or overlap of the two. Oh, we already did a Venn diagram for this. Good. Find the probability that person uses neither Facebook nor Instagram. That would be adding up the three we have and trying to get from 100% of the people have to be represented. So there are 29%. I'd be in that group. And there we go. Okay, let's try a couple problems. According to a recent report, Pandora and Spotify are the most used music streaming apps. Never opened up either one. A group of APSTAT students surveyed all the seniors in their school, found that 68% use Pandora, 38% use Spotify, and 24% use both. Wow, both. That's a little crazy. It's extra money there. Suppose we select a senior at random. Okay, make a Venn diagram to display this. Okay, so let's just kind of do that. So we're going to do a Venn diagram. We're going to say this is P for, you would write the word. It's hard to write on this. So S, Pandora and Spotify. I guess we could, it says we could use so both 24%, so 0.24 is in the middle. Pandora is 38, so 38 minus 24 is 0.14. And 38 minus, Spotify is, this is 0.14. Yeah. 68 minus 24 is 0.44. And again, to get the 14, we did the 38 minus 24. And so now we have the correct numbers in there. Make a Venn diagram. Perfect. Find the probability the person uses neither one. So that's the outside here. They don't use either one. So you would add up those three, 44 plus 24 plus 14. That's 5, 6, 7, 8. So 82. So there's 18% that don't use either one. See if we're right. We were. Okay, last question. So in the 2016 Summer Olympics, the United States and China won the most medals. I kind of remember that. We randomly selected a medal from the 191 that are represented in the two-way table. Define the events G is gold, U is United States, B is bronze. Okay, so this notation I need you to know. So this that notation there, it says, let me get out a sheet here so I can talk about it. When it says the probability of B given U. So what that means is given your United States. So we're only talking about United States, folks. So that's my denominator. So this would equal, there's 121 people in the United States. What's the probability that you're bronze? That would be 38. Again, so the notation is given, what's the probability that you're bronze given that you are from the United States? Given that the chosen medal is not a gold medal, so no gold medals, that's the given, no gold. So I want silver and bronze. What's the probability that came from the United States? So in this case, the given is, so let's just write it out. Probability of that it's from US, given that it's, I'm just put gold and complement there, I think. Does that make sense? That's the notation for this. That it's not gold is what we're saying. Given that it's not gold, what's the probability of USA? So the denominator would be not gold. So how many folks are not gold? So we have 55 silver and 64 bronze. That's 109. No, wait. Let me just add that to be sure. 55 and 64. I think that's not 109. That's 119. Sorry about that. Okay, and then so then we want, so out of those who are not gold, so all those silver and bronze, 119 folks, I want to pick USA. So USA, of those two columns, 37 and 38, I'm going to add those up. You get 75, so it should be 75 out of that. As a probability, and again, statement using correct symbols. So yeah, and they use the symbols there, right? So you got to get used to that symbol. You can use the abbreviations or the long way. You see they wrote it out or they did not write it out. Either way works there, and that would be okay. Okay, that's your lesson for today.